You went to the assembly last week. Isaac, did you find it? We roll on with 4.4. This is a big day for you. Big day. It's actually not super difficult, but you're going to learn. It's one of those days where you learn something that you're going to use a lot. Okay, so let's make sure we have a good one. I'll get a test done. You got to think, when algebra is like playing the buzzer game, I can't grade them, period, too. That's the way it goes. So I've got most of them graded. I'll finish them up at some point, hopefully today. You can check. The ones I have graded so far, they look pretty good. They look pretty good. I think a lot of you came in pretty well prepared for it. Okay, but we still got a long way to go in chapter 4. Okay. Let's see. So a couple cleanup things that you might have seen yesterday. I enjoy a lot of things about this picture. I didn't realize chocolate Uncrustables were a thing. Have any of you had them? Are they good? They're good? They're not rats.
They're mice.
Ryan, what are they? Thank you. Okay, I guess we had to clarify that. These are journalists. Okay. I enjoy the Slim Jim as well. Okay. Our shoes also. Pretty good period. Round of applause for us, period 1. Okay. Listen, it's a little different. I know tomorrow, this is only 8th grade or 7th grade, it's got nothing to do with you. 8th grade is tomorrow, this accelerated literacy field trip, whatever it is. Isn't it?
Yeah.
But you're here till 8:45, I think. I think that's what I read. I believe I read that you will come here, but I can't deal with you right now, man. DMSAR, admin, you gotta wait. Okay. Right. Hopefully Miss James can help you, otherwise I'll be over. Okay. I read that 8:45, I think you're here. Okay, until then. So shouldn't be a big deal. Okay, this is more for period 5 later. Okay, but we're actually gonna skip 4.5 only because this is an Algebra 1 review. I figured I would throw it on the schedule for tomorrow, and then we will do 4.5. So you're gonna skip 4.5, do this, and then come back to it. You essentially just need to follow these directions. It shouldn't be too bad. You'll probably get to see what they are since you're going to be here, okay? But just to clarify, okay? 7 carries, if you're like, what's going on? I'm not sure. Okay, only a couple of warm-ups to do. You've got 1 and 2, and I want you to do the fake literacy. I will do it with you, though, I promise, okay? Go ahead and knock those out really quick.
That's all me.
How'd we do on the first set? Take a quick look. Good? You also could have written it as RCJ. That's not wrong, but why write more? Trust me, with the rest of chapter 4, you're not going to want to write any more than you need to. Okay, at all. Guess I should, all right? Oh. Have we come around to the reflexive property? We don't hate it anymore, right?
No.
Good. I think there was some anger toward it when we first learned it. Now you're like, okay, it's not that bad. Okay? I do have people that are confusing it with the symmetric property. I do want to take just a moment and reflect on that. The symmetric property just means you're reversing things. So if A equals B, then what? Yeah, it's not the same thing. Okay, reflexive is something is equal or congruent to itself. So don't get those interchanged, okay? Let's see, which of these are showing reflexive property? A little round of yay or nay.
Yay.
Yay. Let's go fast.
Yay. Yay. Yay.
You did that quickly. Okay. And then, proof or proof in geometry, which should be capitalized, let's be honest. What, is that 3 marks underneath when it's supposed to be capitalized? That seems excessive.
I thought it was 2.
Is it? I don't know. I just asked. That's why.
That's
How many underlines?
3.
That seems excessive. What does 2 underlines mean? Well, why can't we use that?
I thought it was equal. It looks like an equal sign.
Just, okay. How many equal signs are you running into in your literacy class? Exactly. Okay. In geometry, you love them. A proof uses definitions, postulates, and theorems to prove theorems. D. I don't even know if it's true. I'm pretty sure it's true. Okay. And what's we say? He can prove when he bought the computer because he kept his proof of purchase. Proof of purchase is essentially a receipt. Okay. Cool. All right. So thought you did a pretty good job. Okay. I'm going to lead to some just discussions. Okay. I don't think you need to write anything for these. I just want you to have a conversation. Yay or nay, and how do you know? And how do you know? You guys, quick. Great. Yay or nay? Hello. Yay or nay? Because of what? Okay. Shh. Okay, we're going somewhere with this. Okay. Yeah, they didn't orient it for you, but we're here. Red, pink, this is the included one. That's congruent because of ASA. Okay? Same conversation here and there. Let's have a little bit quieter. And then how do you know? Okay. Yay or nay, are the triangles congruent? Oh, I heard a mixture. Okay, well, let's think this through. Okay, yeah, I'm still hearing a mixture of yay or nay. Why don't you talk about it again? And be confident in what you have. Okay, we're going to try it again. Ready, set, yay or nay? Yay. Okay, now it's not oriented the way that you probably like. That's why you had to think about it. Okay, but we can get those triangles congruent. All right, Sass. Okay, one more for you. And again, make sure she's lined up properly. Yay or nay? Yay. Now, yeah, if you can just rotate it and then you can see everybody lines up. Reason. Okay, cool. Now, I don't know if anybody read the questions. That's not what any of the questions on the board were asking. Did anybody actually notice that? Yeah, that's actually not what they're asking. You were just telling me whether or not the triangles were congruent. So I want to backtrack. Now that we've established these all prove triangles congruent, they want to know, given that these are congruent triangles, is AB, which would be here, congruent to PQ, which would be over here? Now we don't just want to say yes because the triangles are congruent. Let's make sure that they're the correct corresponding pieces. Okay, so I've got red and unmarked, so these pieces correspond. So would you say then that these pieces are congruent?
Yeah.
Why?
If you're congruent.
How about we raise our hand and give me one instead of just a bunch of gibberish? Elena.
If they're congruent, then all the sides and all the angles are corresponding
Okay,
angles.
so let's remember how we started chapter 4. Before we got to all the fun stuff, ASA, SAS, SSS, and what was the last one? Okay, before we got to that, these are shortcuts. They are postulates and theorems, because remember, one of them is actually a theorem, the rest are postulates. They're shortcuts that say if you get that, that's enough to prove they're congruent. But the original definition of congruent triangles was you had to have 3 sets of congruent sides and then 3 sets of congruent angles. So now we're kind of using converse. If we know that the triangles are congruent, then we know the pieces must be congruent. That's where we're going with this today. So that's actually the question that they asked, okay? So this one, let's make sure everybody lines up. Okay, we established the triangles are probably congruent by SAS. Is AC congruent to PR? Would appear so. There is no third side theorem, as some of you tried to write yesterday. Like there's third angle, there is no third side, which we will get to later in the chapter, okay? And then the last one, okay, we have them established as being congruent by side, 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 is angle B. Angle B is in between green and blue. Congruent to angle Q, right here. What would you say? Yes. Okay. So I want you to understand what we're doing. We're not just proving triangles congruent now. We're going to finish the job. But all the little abbreviations you wrote yesterday, all the fun stuff, those are shortcuts. Where you can establish congruence with only limited information, but the rest is still true. So you're going to learn, this is a big one, you're going to write it so much, we're allowed to abbreviate it, okay? So there is a big thing right there if you flip to the next page. First, let's fill in the blank. If two triangles are congruent, then in the blank, their corresponding parts are congruent. That's the first thing you should write in your blank, okay? And then beneath it, I want you to write CPCTC. You are going to write this so much. If you know anybody that's taking geometry, provided they took geometry successfully, they probably remember CPCTC. They might not remember what it means, but they should remember that it happened, okay? See if you and a partner can figure out what that stands for. See if you can figure out everything it stands for. Without looking at my notes. There's 2 extra words in there. There's 2 extra words in there. 5, 4, 3, 2, 1. Now, we're all going to go through it together. Ready? Corresponding parts of. You got to put the of in there. That's the one of the extra words. Corresponding parts of congruent. There's an extra word here. R, that's the extra word. Congruent. CPCTC. You have to put the of and the R in there. Otherwise it reads corresponding parts, congruent triangles, congruent. That's a bunch of nonsense, okay? Now, let's understand it, and then I will tell you, you never, for me, need to write those words out ever again. It's going to get old. You are allowed to and encouraged to just write CPCTC. You're going to use it a lot. That's why we abbreviate it. And this isn't just our geometry class. This is like going back to the dinosaur era when I was in high school. We wrote CPCTC. Okay, first you have to understand exactly what it means and how you would use it. We just established, if we know the triangles are congruent, then all their corresponding parts are congruent. We just use CPCTC. So look at this example on the board with the kind of yellow and the bluish one right there. Okay, this is nothing. This is just fun. I think it's fun. Okay, that's good. Okay. Given this information, let's see if these triangles are actually congruent to each other. We've got these angles, and then a non-included side. Are those triangles congruent to each other?
Yes.
Due to what? AAS. So if we were actually doing a proof, we would say, you don't have to write any of this, triangle ABC is congruent to triangle. Some of you noticed there was one out of order yesterday. A lot of you noticed it. What would I have to say? Say it. ABC is congruent to, okay, by, what did we say? No. AAS. Now that we know it's congruent by AAS, we can then say any other parts are congruent and they would all have the same reason. CPCTC. So I could say AB is congruent to DE, and guess what my reason would be? CPCTC. I could say angle A is congruent to angle D, and guess what my reason would be? And there's one other one that we don't have yet. BC is congruent to, same reason, all three of these CPCTC. There's a reason I'm not going to make you write out corresponding parts of congruent triangles are congruent, because you're going to be writing CPCTC a lot. Quiz. Can you use CPCTC without knowing that the triangles are congruent? No, look at what it says. It tells you what it is, okay? So CPCTC is going to come up a lot. It's a big thing for you. I'm not saying it's hard. I'm saying it's going to come up quite a bit. That's why we abbreviate. That's why we use it, okay? So I want you to look as a group right now. There's 3 of them down there. They give you some information. They give you this and this. They want to know, can you conclude angle B is congruent to E, etc. There's 3 of them. I think you should talk about them. Go ahead. They're at the bottom. It's either a yes and then tell me exactly how you know, or a no. And if it's a no, it's a no. Okay, I think you should talk about them though. You're given this information, can you conclude this? And I want to know how you know. And if it's a no, it's a no. Just those 3. I know there's more on the next page. I want to make sure we're approaching these questions the right way. I'll also show you how you're supposed to write your responses. You might not know that yet, but that's okay. This is your first one, right? I think I switched them. Is this your first one? Yeah. Okay, cool. Just 3 of them. It's okay if you're not 100% sure. That's why I don't want to do them all.
You get here, right?
Just go pencil down when you've done all 3. You might just need some cleanup in terms of what work you show. You do have to give some explanations. This will show you what they are. Little CPCTC. Pencil down when you've done all 3. You'll see what you need to write. If you said yes, you're going to have to write the correct equivalent statement. Yeah. That's step 1. That's what we're going to talk about. Okay. Now, Louis just asked me the question that you should know, that I kind of hinted at, but we'll come back to it. Louis, what did you just ask me?
Do we know that the triangles are?
What's the answer? No. However, the onus is on you to prove them congruent. That is step 1. So when you're approaching these problems, the first thing you have to establish is, are the triangles congruent? Okay? I can't use CPCTC unless I know the triangles are congruent. Okay? So let's actually start with this first one. A lot of you have it, but some of you don't have enough work. I'm going to show you what the work is. It's not that much, but still. Okay, so we're given that angle A is congruent to C, ABD is congruent to CBD. You should totally mark it. The first question you ask is, can I get these triangles congruent? You can't use CPCTC unless I establish congruence. I actually can. Somebody tell me, what do I need to do to establish congruence? Jazzy. Okay, the first thing you'd have to do is mark this, and this is what I need for work out of you. I need you to say BD is congruent to BD. We'll have to write reflection. This isn't a full-blown proof. We can't use CPCTC yet. We have to write down an equivalent statement. Okay? Louis,
Angle ADB is,
I don't need it. Nope. Don't need it. You love third angle theorem. It's not necessary. Can we get the triangles congruent?
Yes.
What do we have? Triangle. You have to write this though. You can't just write AAS. You have to say that the triangles are congruent. So we're going to write triangle ABD is congruent to triangle. Yeah, I got to go in the same order. CBD. What can we write just next to it? AAS. And now that we've done that, we can say AB is congruent to CB. And what's our reason for that? This is what I need to see out of you. This is non-negotiable. It's not a full-blown proof, but it does provide reasons. Okay, some of you just walking around, some of you just wrote AAS. You have to say the triangles are congruent. That's necessary. Some of you just wrote CPCTC. That's not enough until you establish congruence. Okay? Cool. How does that one look? Because if this one doesn't look good, the rest aren't going to look good. Okay. The second one, okay, which actually I had up first. You're given that BT is congruent to EU. So BT is congruent to EU. BU is congruent to ET. So I'm right here. There's actually only other one thing I can get true. Anybody know, CC? I can get those because they're vertical. Can I get anything else on this that matters? You can't get those triangles congruent. You can try, but you can't. Okay? I need angle B congruent to E, which means I need this triangle congruent to that triangle. I'm out of luck. I need more information. I would need one of these sides, or I would need another angle. This one is not possible. I think a lot of you did write down that this one wasn't possible. Okay? And then one more, then I'm going to have you do a couple others. I told you the overlapping triangles were going to be a thing. It's a love-hate, but you can get better at them. I like to separate them. I'm going to do that. Okay, so they want to know if Rn, so what's Rn? Is that right here? Is congruent to On. So let's really think this through. If I want to get Rn congruent to On, which triangles would help me? Triangle what? CRN in triangle. Okay, those ones would help me. If I can get this triangle, I'm going to outline them. If I can get this guy congruent to this guy, if I can, then I have license to use CPCTC. Those are the ones that matter, okay? Well, maybe I don't need to redraw these ones. Let's see what they give me first, okay? What information do we have, everybody? CN is congruent to WN. We have angle C. Well, I'm actually hear people chiming in. To W. Okay? Can we get other information? We actually can. Grace. So these guys are congruent. Oh, did we get the triangles congruent?
Yes.
So you need to write this. A lot of you did not. We need to write triangle CRN is congruent to triangle WNO. And what's our reason, everybody? ASA. So now we can say RN is congruent to ON, and our simple reason, CPCTC. Okay? Yes? No. Don't write a proof. Yes? No, you just need to establish, if you mark the diagram and you write this, that's enough for me, okay? So a couple others, okay? There's two of them. Try the next two. Please talk about them. What triangles are we trying to get? And then can we use CPCTC? 4.4, you're going to catch up.
Oh, I see. Wait, because they share the house at CH. I know it is CH. But it still wouldn't work. I'm redrawing this one. It's EAM.
I definitely redrew on the second one. Not this one, the one after it. What?
It's pretty when you're inside.
Oh, I do.
But outside,
Pencil down when you're done with both of them. Let's see where how it went for you. All right. Looks like we're good. Sounds like we're good. Okay. So. The name of the game is, if you're not going to redraw the triangles, that's fine. But the conversation should be this. Okay, which triangles would get the job done? If you can get the right triangles congruent, you can always use CPCTC. The question is, can you get them? Okay, so you're given that CS is congruent to HR. That's cool. You're given that 1 and 2 are congruent. Okay, that's cool. Here's the real question. CR is congruent to HS. So in my mind, I'm like, okay, I need to attack the correct triangles. Don't I want this one congruent to, you can tell me if you don't, but don't you want those to be congruent to get the job done? I redrew them. Okay, in my mind, I'm like, there's way too much going on. Everything's crossed up. I'm getting cross-eyed. So I redrew the triangles, and now I'm going to mark the pieces. And if I can get these congruent, yes. If I can't, then the answer is no. Okay, so I'm given that angle 1. Let's start with this triangle first. Okay, RCH, this is angle 1. Okay, and then SCH, this is angle 2. Okay, so I got those congruent. And then what's the other piece you're given? CS is congruent to. Okay. Now I heard a couple of you're really thinking this stuff through. I heard some people say you can get HC congruent to itself because of what? I heard people say that. That's cool. Why is the answer still no? Why is it no? Ava? Correct. You can't get those triangles congruent. The best you can get is SSA. SSA is not a thing. So even if you did this, that's so cool that you can't get the rest. Okay? And remember, you're going to hear it so much, You can't use CPCTC unless the triangles are congruent. There's not a way to get them congruent, okay? How's that first one look, okay? Not okay? I would highly encourage you to redraw the overlapping triangles. Okay, so let's look at this next one. MN is congruent to MA, okay? So, and if you want to mark your original diagram, that's cool, but MN is congruent to MA. ME is congruent to MR. Those are bigger pieces. I want to know if angle E can be congruent to angle R. I don't know if that's true, so I'm not going to really mark the diagram. I'm just going to show you where they are. So I decided the triangles I really want are this guy, this tall guy. So is that EMA? And then what's the other triangle that would help us? This guy. Those are the ones that if I can get them congruent, I can use CPCTC. Okay? So I redrew them. Okay, let's mark our information again. Given that MN is congruent to MA, what else do we have? ME is congruent to MR. Okay, is angle E congruent to angle R? This one's actually a yes. Does anybody know why this one's a yes? Cora.
Because angle M is congruent to itself,
Mm.
and then you get SAS.
Now, I'll bet a bunch of you drew a right angle in. Dave, I draw a right angle in. That's just reflex. You don't know if it's reflex, if it's a right angle. But it's definitely congruent to itself, no matter what marking you draw. No. So I can say angle M is congruent to angle M. Oh, I have side angle side. So I would say triangle MNR is congruent to triangle, I got to be consistent, MEA, by side angle side. And then I can use angle E congruent to angle R, and my reason is CPCTC. Okay, good job. Caleb, question?
If you did not use the right triangles, could you
We
find
don't.
out
Doesn't
ways
matter.
to use,
Doesn't matter. Stay tuned to later in chapter 4. If we knew there were right triangles, there's other ways we could approach it, but we don't. Now, if you drew a right angle in by reflex, I mean, you're okay, but you shouldn't actually put that in. Did anybody draw a right angle in by reflex? Liars. Anybody missed the boat entirely? Okay. Good job, Cora. Questions about it's tricky. I never said this is easy stuff. I'm like, you gotta be really careful. So it's step 1. Find the triangles you need. Step 2, see if you can prove them congruent. If you can, CPCTC. You can do whatever you want. If you can't, the answer is no. Okay? Cool. Okay, so let's recap it a little bit. Look at a couple proofs. Okay? So this is kind of backtracking, but that's a little bit of what we're doing today anyway. Okay, so given in this diagram, BA is congruent to DA, CA is congruent to EA. Let's get something out of the way. I said it earlier, because some of you tried. There is no third side theorem. There's a third angle theorem. There's no third side theorem. And later in chapter 4, we'll talk about why, because actually these could be various things. So you can't do that. If you try to do that, you need to stop. Okay? But we need to prove that angle C is congruent to angle E, okay, which we have right here. Well, this is a wonderful recap. We have 4 ways to prove triangles congruent. What do we got? Everybody starts with SSS. And cool. The given states that we have 2 pairs of congruent sides. Okay, so right now we're down to 2 options. We're down to either SSS or SAS. Those are the things that we have. Well, let's see if we can do it. Okay, I'll bet we actually can. Okay, so they actually told us, we're just going to do a little fill in the blank proof. BA is congruent to DA. CA is congruent to EA. Reason? Good job. There is no third side, but we can get the angles. We got CAB is congruent to EAD. Vertical angles are congruent. Vertical angles theorem. VAT. Yada, yada, yada. Okay? I'm going to mark the diagram just because I can. So right here. Cool. We can't use CPCTC yet. I know you're very excited. You can't use it until this next step, which is establishing congruence. Reason? Now we can say angle C is congruent to angle E. We get to a point where we're just writing a bunch of letters down. That happens in a lot of chapter 4. Okay? Aren't you glad you can abbreviate it CPCTC at this point? Oh, you don't care? Okay, then every time you have to write out corresponding parts of congruent triangles.
I love it.
Thank you. That's what I wanted to hear. Great. Okay? I want you to try a couple proofs on your own. There's 2 of them. Hint. You're going to use CPCTC.
Give it. It's congruent to ACB.
Okay, now there's also potential for possibly next year. I know. I was waiting for it a couple weeks ago because I knew this was coming. Legendary group costume unlocked for next year. Get a group of people together, CPCTC.
How do you yourself as that?
Use your imagination. It'd be even better if 3 people were like, parts of a triangle, and then 3 people were parts of a congruent triangle, and then you got them together and then you CPCTC. Oh, you could. You don't have to. You'll be in high school. That's a whole.
1, 2, 4 is how I count. They're clearly better than 0.
So I never said that to you last year when they beat the snot out of them. Why are you doing that now? They won 1 game.
It's the only thing I can grasp.
You need something else. No, you need something else. You should be grateful they didn't trade Jalen Waddle away to the Bills because I guess they almost did that. It's nice. Then talk. No, don't meow. Just talk.
Oh yeah, I forgot.
I never did on my test.
I don't know where I wrote
We don't need the third.
Let's go, focus. You gotta lock in so you can clock it at 6, 7. Yeah, see what I did? Put them all together like that. Just gonna speak all these nonsense things in the list. I got the first one done in 4 steps.
Still working. MC, yeah.
You should be rolling through the second proof. We're gonna check them both at the end.
Last year I read 36, 90, 90, so scales.
even read that. I was just that. Say, I already had it.
Oh, wait, wait.
Let's go. Pencil down when you're done with both of them. You should be cruising through the second one. I got the first one done in 4 steps. How many steps for the second one? Yeah, I got 5 for it as well. Cool.
I almost hit one of them. Because he thought I was going to stop.
Oh, yeah.
I thought I was going to stop really far back. Like, actually, it was like this far. Because I was actually bridge. And he was like, that's going to hit him.
Watch. Good luck. All right. Okay. Now problems like this, you gotta really make sure you're okay with because there's no overlapping triangles, there's a shared side. That's not the same thing. So you should know exactly what you want. Given that angle KBC, it's nice when they mark it for you as well. I wouldn't get too used to that. It's congruent to ACB. Angle K is congruent to angle A. So you should already be thinking to yourself right now, I've got 2 angles, probably just gonna need a side. Okay, well we put our reasons in for the given. Okay, Moxley, what'd you do as your first step on the next one?
For my first step on the,
Yeah, the second step on this guy.
my second step was BC is congruent to BC,
Reason?
reflexive of congruence.
Good. You're getting better at writing congruence. Some of you did miss it yesterday. I do take off a half point for that. It's kind of silly. Okay? So now we're here. Okay, we cannot use CPCTC yet. I know you're excited, but Jack, what has to happen next?
You have to prove
Not equal, congruent. Can we?
yeah,
By what?
on AAS.
Good. So we would state triangle KBC congruent to triangle ACB by AAS. Now we can use CPCTC. We want KB congruent to AC. CPCTC. No? Wait. Good. I did have to take off for it a little bit yesterday. I told you I would. I said I wouldn't on the first test. I said it might hurt you a little bit on the second. I didn't take off a lot, but it did make me sad. You gotta close it out. Okay? The last one. Now this one is more steps. Okay, it's not significantly more, but you gotta be a little bit more cleaned up on this. Given that AB is congruent to AC and M is the midpoint of BC. A couple of you yesterday, you'll see, some of you confused angle bisector with segment bisector, and it like hurt. Okay? So this is not an angle bisector as far as we know. We know that M is the midpoint of BC. Okay? Well, we have our givens. Okay, it's always nice to start out with that. There's a couple ways you could go next. Sari, what did you say is your next step?
We said MA is congruent to MA.
Okay, how many of you went step 2 just to get it done, get it out of the way? MA is congruent to MA. How many of you did it step 3? Okay. This is interchangeable. I have it as my step 3. Okay, some of you have it as 2. It doesn't matter. Okay, somebody want to tell me what their step 2 is then otherwise? Okay, TC. BM is congruent to MC. What's your reason for that? Good. That has to be definition of midpoint. Okay, there's no other reason that you can give. So we have BM is congruent to MC, and then I'm going to flip and then do series for number 3. Okay? Those should be steps 2 and 3 in either order. I don't care about the order. That's the one I did. You can flip it. You can't talk about the angles. I know it's tempting. I can't declare those congruent. I don't know it's an angle bisector. I just know it's a segment bisector. For all we know, it could be written like this, where it's clearly not segmenting the angles, it's or bisecting the angles, only the segment. Okay, cool. We can't use CPCTC yet, but can we get the triangles congruent? By what? SSS. Yeah, we don't have any angles. Okay? SSS is actually pretty rare. Now can we prove angle AMB is congruent to AMC? By? I told you, you get to a point where like your closing of proofs is just you writing a bunch of letters. Meaningful letters, that's kind of the way it goes. Okay? Questions about that one? I think you did pretty well. Okay, cool. So look at this. Little CPCTC, QED, SAS, ASA. Just start rattling off all your letters. That would be good. Be hard.
That's a good idea to make it tough.
The geometry.
C to the P to the C to C.